Mutually exclusive events versus non-mutually exclusive events. For the probability of mutually exclusive events, two outcomes that have no outcome in common are said to be mutually exclusive. If A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A union B is equal to the probability of A plus the probability of B. Using this illustration, the two given events A and B cannot occur on the same time, so they are considered as mutually exclusive. Example number 1. What is the probability of drawing a queen or a king on an ordinary deck of cards? Getting first the probability of getting a queen. So since we have 4 different suits, we have spade, club, diamond, and heart. Each suit has a queen card. So we have 4 over the total number of cards in a deck of cards is 52. And we have 4 over 52 is simplified as 1 over 13. The probability of getting a king is also 4 over 52 because we have king of hearts, king of diamonds, king of clubs, and king of spades. So we have 4 over 52 or 1 over 13. And since the probability of getting a queen and a king is 0 because we don't have a card which is a queen and at the same time is a king card, so this one is an example of mutually exclusive events. So we can solve this by having the probability of getting a queen or king is equal to the probability of getting a queen, which is 1 over 13, plus the probability of getting a king, which is also 1 over 13. Getting the sum of these, we have 2 over 13. Or 2 divided by 13 is equal to 0.15, or that is 15%. For the probability of non-mutually exclusive events, if two events A and B are not mutually exclusive, then they share outcomes in common, meaning they have intersection. If A and B are events in a sample space S, then the probability of A or B is the probability of A or B is equal to the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Given this illustration, our two given events A and B can occur on the same time because we have here the intersection of the two given events. So these two events are not mutually exclusive. Example number 2. If a card is drawn from an ordinary deck of 52 cards, find the probability of getting a heart or a face card. First, getting the probability of getting a heart. So we have 4 suits, and each suit we have 13 cards. So for the heart cards, we have 1 ace card, and we have also numbered cards 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have also the face cards, such as Jack, King, and Queen. So we have a total of 13 heart cards over 52 cards in a deck of cards. And for the probability of getting face card, so again, we have 4 different suits, and each suit, we have 3 different face cards. We have the King, Queen, and Jack cards. So for that, for 4 different suits times 3 different face cards, we have a total of 12 over the total number of cards in a deck of cards, which is 52, or that 12 over 52 can be simplified as 3 over 13. And since we have face cards that are also heart cards, we have the King of Hearts, the Queen of Hearts, and the Jack of Hearts. So we have an intersection, the shared common outcome. So we have the probability of getting a heart, intersection, the face card, or we have the probability of getting a heart and face card. So we have 3 over 52. This one is an example of non-mutually exclusive events. So to find this, we have the probability of getting a heart or face card is equal to the probability of getting a heart, which is 13 over 52, and the probability of getting the face card is 12 over 52 or 3 over 13, minus their intersection, which is 3 over 52. So we have here 22 over 52, or in simplified form, that is 11 over 26. Or 11 divided by 26, that is 0.42 or 42%. Example number 3. Let us find the indicated probability. For letter A, the given, we have the probability of A is equal to 0.65, probability of B is equal to 0.30, the probability of A union B is equal to 0.75, and the probability of A intersection B, which is unknown. So to find this, we use the formula, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. By substitution, our probability of A union B again is equal to 0.75. The probability of A is equal to 0.65. The probability of B is 0.30 minus the unknown, which is the probability of A intersection B. Simplifying this, 0.65 plus 0.30 is equal to 0.95. And then to find for the probability of A intersection B, we have 0.95 minus 0.75. Getting its difference, the probability of A intersection B now is equal to 0.20. Then for letter B, our probability of A is 0.55, the probability of B is 0.35, and the probability of A intersection B is 0.15. And now, the probability of A union B is missing. So to find this, we use this again. We have the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. By substitution, our probability of A is equal to 0.55. The probability of B is 0.35 minus the probability of the intersection of A and B is 0.15. Simplifying this, we have probability of A union B is equal to 0.75.